Welcome everybody. This is the first video in the series of videos on algebraic expansion. In this set of videos, I would urge you to pause where necessary and try to do the problems along with me. That's the best we can do to make this passive medium a little bit more interactive. First, what is a square? A square is a shape of is a following shape, and so all the equal sides. So you have the area is given by a squared, and this is your basic definition of your square. And so at this point, I would like you to pause this video and try to make a square with side 15 centimeters. With a piece of paper. So please pause the video and try to make a square. Hope you could make the square. To make the square, you need to fold this first, get a piece of paper and make your measurements, which is 15 centimeters, and cut it accordingly, and then fold, and then you can cut it. I'm sure you have done this a zillion times. So now the second activity is, now that you have made a square of 15 centimeters, you need to divide this 15 centimeter square into 4 parts. So this would be, your parts would be like that, like this. Here is 5 centimeters, and these are 5 centimeters, and this is 10, this is 10, this is 5, again this is 10, and this is 5. So this is how you divide your 15 centimeters. So you get 4 squares. So pause this video and try to make these squares. I apologize, you have 2 squares here, 1 and 2, and the other 2 are rectangles. Yeah, so you have to divide this into 4 parts. So pause the video and try to divide this into 4 parts as shown. Now the total area of the paper originally we took up was 15 square. Or it's 15 centimeter square, 15 square centimeter square. That's 225 centimeters square. So pause this video and try to find the area of each of the parts that you have divided this into. So you can note this in your piece of paper, the area over each parts. So hopefully you have found this area as 100, this is 50, and this is 50, and this is 25. So your net area is, you got this as for different parts as 10 squared plus 10 into 5. That's for this. And then you have another 10 into 5 here, plus 10 into 5, plus you have 5 squared here. So what you have is 10 squared plus 2 into 10 into 5 plus 5 square. And that area would again be 225 centimeter square. If you were to make this a more generic problem, wherein you want to divide your squares into the following parts, and this is your a by a square, and this is your b by b square, what you have is the net area would be, you start with, and this is b of course, so this is again b. So the net area would be a plus b the whole square, and that can be opened up as a plus b into a plus b. So the a plus b, you start with a plus b because both these sides are a plus b, so you have a plus b the whole square, which is the area, which is nothing but a plus b into a plus b. So this can be written as following. You can write this as a into a plus b. You can take this as 1 unit, and you can multiply that by that, plus b into a plus b, a plus b. So that's basically this part here, a into a plus b, and then you have the other part, which is b into a plus b. So that's this. And this is a and this is b. So that's b into a plus b. So that's the area. You can further divide this into a squared, and that's this. A into a is a squared plus ab, and that is this. That's this. Plus BA, and that is this, plus B squared, and that would be this quantity. So further you can write this as a squared plus 2ab plus b squared. So that's how you can generalize a plus b the whole square. As an extension to the above expansion, which is a plus b the whole square is a squared plus 2ab plus b squared, if you substitute minus b instead of b, that become a plus minus b the whole square, and that's equal to a squared plus 2a into minus b plus minus b the whole square. So, or in other words, a minus b the whole square is a squared minus 2ab plus b squared. So with this, you can also look at this visually. If your whole of the square is a squared, if this is your, if this is a, then this represents your a squared. And this quantity minus 2ab, it says you have to remove ab twice. So let's divide this square into two parts, a minus b and b. So that's, you divide that a minus b and b, and there you go. So this is b and this is a minus b. So you have removed this piece from the entire a squared. That's a squared minus 2ab. You would have to remove one more piece of ab. That is, but then you don't have, you have only this much. So that's, if I were to put one more layer over this, so I have to remove only this quantity from the main square to get my a minus b the whole square, which is the whole thing is this is a minus b and this is b here, right? So this part is your a minus b the whole square. So to get this, I have to remove, first I removed from a squared ab, one ab, and then I am removing the second ab. But then when I'm removing the second ab, I have this part which is being removed twice. So for this reason I have to add it back. So that's plus b squared. That's why this plus b squared comes. Which is another way to visualize this would be, you have these two sheets of a cross b, and you have another sheet which is a cross b. Now you take this and then you put this in, put this above, you get this. So you have this extra thing that you have to tear it off, and this extra thing is b squared. This extra thing is b squared that you're tearing it off. So the net area of this L shape is 2ab minus b squared. So the net area of this L shape is 2ab minus b squared. This is ab plus ab, which is 2ab, and then minus b squared because you tore off a piece of paper. And that's what you're subtracting it from a squared, from the net whole a squared, because this whole thing, remember, is a, from which you're removing this L. So a squared minus 2ab minus b squared, and that is nothing but a squared minus 2ab plus b squared. So that's how you get this expansion of a minus b the whole square. You may also do this algebraically, which is a minus b the whole square is a minus b into a minus b, that is a into a minus b into a minus b. That's a squared minus ab plus b squared. That's equal to a squared minus 2ab plus b squared. At this moment, I would encourage you to pause this video and try to derive this a minus b the whole square expression by yourself, and maybe even try to convince yourself visually why it is indeed the case. Moving ahead, the next expansion that we want to see is, hey, what is a squared minus b squared? So I guess this is the sixth in the list we are seeing. So 6 point. So a squared minus b squared. So visually this is quite straightforward. So you have a square of a into a, and from this you remove this much part. So this is b squared. So you remove b squared from a squared. So this is nothing but a squared minus b squared. Now, to have an alternate view, you can actually cut this sheet of paper, if it is a paper, at this point. So what you have is, here you have b, and here you have a minus b. And what you can do is you cut this piece and bring this piece of paper here. So that would make this, it would give this a little bit of extension, and this would make this give a b to this. This make it a plus b. So the same area, a squared minus b squared, is a plus b into a minus b visually. But then algebraically you can go ahead and do this and convince yourself that it is indeed the case. So this becomes a into a minus b plus b into a minus b, which would be a squared minus ab plus ab minus b squared. That's equal to a squared minus b squared. So that's how you can algebraically also convince yourself indeed this identity is valid. Here is a summary of all that we have looked so far. You have a plus or minus b the whole square would be a squared plus or minus 2ab plus b squared, and a squared minus b squared is a plus b into a minus b. In the next video we will look into some problems involving these expressions, some interesting problems and common type of problems involving these expressions. I hope you enjoyed this video. See you in the next one. Bye.